So in question 4, we're given 2 points. We've been dealing with situations like this for quite a while now, and we're asked to find three separate things related to these 2 points. First of all, we're asked to find the equation of the line that goes through those points. The other thing we're asked to find is the length of the line segment, and then finally we're asked to find the midpoint of that segment. Um, so let's start with the equation of the line. Um, Really intentional here, right? I'm I'm going to find the slope first, and after I find the slope, I'm going to find the y-intercept. And the way that I'm going to find the y-intercept this time is by using y equals mx plus b. I'm going to plug one of my points into that equation and the slope that I found, and that'll help me find b, my y-intercept. And then I'll know the two parameters. I'll know both the slope and y-intercept, and I'll be able to write my answer. So let's start with the slope. The slope is the change in the y values. In an xy coordinate pair, we have an x and then a y. We have an x and then a y. So when I write change in y, I'm saying I'm trying to find the difference between 2 and -4. So just the way I said it, I need to find the difference between 2 and -4. If I write 2 minus -4, that's the difference, right? The difference from two things is obtained by subtraction. So I can just write it exactly like this, 2 minus -4. Um, I also need to find the change in x, the difference in the x's. To do that, I am going to look at my x values. I've got a 2 and a 6. And to find the difference between 2 and 6, I'm going to write 2 and then -6. So in my numerator, 2 minus -4, I have the number +6, right? 2 minus -4 is +6. In my denominator, I have 2 minus 6, which is -4. So my slope will simplify to -3/2. This is the slope. 6 over -4 is equivalent to -3/2. Now, I know the slope. That's one of my two parameters. Right here, it's the m. I don't know b yet, and that's my y-intercept, and I'm going to find that next. To do so, I'm going to use one of my points, and it doesn't matter which point I'm going to use, or which one I use. I'll use this first point. So on that first point, it says y is 2. That's in purple. So I'm going to write the 2 here. And that's going to equal my slope, which is -3/2. And I need to multiply that by the x value, which is 2 from my point. You can see that in green. And then plus b. Well, when I multiply -3/2 times 2, it just becomes a -3. So take a look at it. You can see where I was and where I'm at. All I changed is the fact that -3/2 times 2 is -3. And then finally, I'm going to add 5 to both sides, and I get that 5 is what b is. So the equation of my line, I think, is y equals -3/2 times x and then plus the number 5. This is the equation of my line. Now, it turns out we can verify this, right? We can look at it and see that this is actually the case with our calculator, and I want to do that. This is the equation of the line if both points are satisfied by this equation. So let's check our second point when x is 6. So I'm just going to enter -3 divided by 2. That's -3/2. I'm now going to multiply that by the number 6, and I'm going to add to that the number 5. And you can see when I do that, it gives me exactly what y should be. It gives me -4. So when x is the number +6, you can see that y becomes exactly -4. Perfect. I can do the same thing for the other equation. I'm just going to go up, up, grab this line, and I want to just go over and just modify my x value. Now, by changing that x to the number 2 when I press enter, I should get +2 for my y, and you can see I do. Okay, This is exactly what I'm looking for. This is the equation of the line that goes through those 2 points. The other thing we're asked to do is find the length of the line segment AB. So I don't need this sketch, but I think having this sketch might be helpful. So I'm going to go ahead and do a quick sketch here. I've got x is 2, y is 2. I've got x is 1, 2, 3, 4, 5, 6, and y is actually negative 1, 2, 3, 4. So here's the other point that I have. And this question is asking me to find the length of this segment. In other words, how far is it from one point to the other? And whenever we're doing this on the Cartesian coordinate plane, we invariably get to a point where we want to consider a particular right triangle. And I know that this is a right triangle because it's got a vertical line, right, that's parallel to the y-axis, and it has this horizontal line that's parallel to the x-axis. This vertical line has a length that is exactly 1, 2, 3, 4, 5, 6 units. And I can look at it, I can say, how do I know that it's 6 units long? Well, look, I'm starting at positive 2, right? Way up here, you can see my y value here is at positive 2, and down here, my y value is at negative 4. And I can see that by looking at the original problem, right? Here's positive 2, and here's my negative 4. So if I'm traveling from 2 to negative 4, that's 6 units long. And you can do it either way. You can go 2 minus negative 4, and that will give you positive 6. But if you went negative 4 minus 2, it would give you negative 6. But remember, we're talking about the length of this line segment, so we would take the absolute value of that. So that's 6 units long. Similar thing along the bottom, right? I'm going from a positive 2 to a 6. This has to be exactly 4 units long. So if I need to find the length of this hypotenuse, I'll call it d for the distance between these 2 points. All I'm writing here is that the distance squared, right, the hypotenuse squared, is equal to 6 squared plus 4 squared. So this distance squared is 36 plus 16. And when I take and I add 36 and 16, I believe I get 52. So I'll come down here and write it. The distance squared is 52. So d itself would be the square root of 52. And there are 2 roots here. There's the positive and negative root. We're just looking at this principal root, the root 52. This can be simplified because it does have a perfect square. It's divisible by 4. I can simplify that as 2 root 13. But probably what most of us would do right now is write down that that is equivalent or approximately 7.2. So if I'm starting way up here at point A and I'm traveling to point B, this distance between those 2 points is 7.2 units. That's how far apart they are, 7.2 units apart. Last question part of this is to find the midpoint of AB. So it's somewhere in this region here, right? It's somewhere in the middle of those. And we've talked about looking at midpoint as taking the average of our x values and the average of our y. So if I was to copy those points again here, I could say that this definitely has an x and it has a y. The x value is going to be 2 plus 6 divided by 2, which is 8 over 2, which is 4. So my x coordinate of the midpoint is at 4. My y coordinate is at 2 plus negative 4 over 2, which is negative 2 over 2, which is just negative 1. So the location of this midpoint is when x is 4 and y is negative 1. And I can look at this sketch and I can say, yeah, that looks pretty much like it's in the right spot. X is over 4 units and y is down 1. And you could plot this too if you wanted to look at it on graph paper, but pay attention to this procedure so that you can do this quickly and efficiently and not need graph paper every time. So those were our three parts for question number 4.